Yeah, my name is Joseph Veaugh-Geiss, and I'm working with KDE. And the talk today is going to be called Achieving a Circular Economy with Free Software. It overlaps a bit and I hope complements the great talk earlier today from Fairphone by Luca. I'm also going to try to reference some of the other projects like the Frameworks project, which is also totally relevant, and Asahi Linux, which is also in the slides today. I'm the one who's privileged to be up here on stage, but actually the real work is done by the community. And I'm going to try to remember to acknowledge them throughout the slides. Of course, I won't be able to acknowledge everybody. This work is also, in part, was funded by the German German Ministry for Nature, Conservation, Nuclear Safety, and Consumer Protection. In a project which went from 2021 to 2023 and is now and was also partially supported by the KDE nonprofit, which is a great nonprofit supporting thousands of volunteers to do great work developing KDE software. We're running a fundraising campaign right now. Check out the website if you want to support us and what we're doing. Two warnings in my talk today. So one is it's a bit depressing. I'm really going to go into some of the more depressing aspects of the climate crisis right now and how it relates to software. And a second warning, I'm going to quote the Pope, not for religious purposes, but there was a recent publication that's relevant, and even the Pope is raising red flags about what's happening in the climate. All of the slides have lots of links and sources in them. You can download them from the repository. I'm going to leave this up here, and to get started, I usually like to ask the public a couple of questions to start some interaction. And the first questions are just going to be yes or no questions. If you feel that the answer is yes, just raise your hand, okay? So my first questions are related to what you associate with free and open source software. So who here associates collaboration with free and open source software? Okay, most hands are going up. Who here associates free and open source software with passion? Okay, a lot of the same hands. Who here associates it with autonomy? Okay. Transparency. Great. Sustainability in terms of environmental sustainability. Okay, many less hands now. I hope by the end of this talk, I convince all of you that the next time someone asks that question, you will raise your hand. Okay. A couple more questions before we get started. So who here is familiar with this symbol? Another yes, no question, raise your hand. Yeah, okay. Who here can tell me what the 3R are? So go ahead and just yell it out. Reduce, reuse, and recycle. These are the three main topics that I'm going to focus on today in terms of the circular economy. Of course, it's a more complex topic than that, but I'm going to reduce it down to these three. Okay, one last question. This is a collection of essays that many of you may be familiar with. Who can fill in the blank and just yell it out when we get to it? Free software, free society, okay? How do we get from one, free software, which is a technological issue, to the other, which is free society, right? Which is a social issue. And I'm going to focus on two inherent qualities of free software, that is autonomy and transparency, in terms of how they relate to the other qualities that we associate with free software. In this case, it's free society, so it's a social issue. And one of the main points I want to make is that transparency and autonomy are not features added to free and open source software, right? These are inherent to the choice to develop free and open source software by design, right? You decide intentionally to have transparency and autonomy be part of your software development when you release your software under a free and open source software license. And I want to take those same two inherent qualities, the autonomy and transparency, and I'm going to argue that this is software design which enables the 3R, right? And there's a term for this. When you design your products to enable the 3R across their life cycle, that's called the circular economy. And a shift to a circular economy would have huge environmental impacts. There's one estimate that suggests that just shifting from a linear to a circular economy could reduce global greenhouse gas emissions by up to 70%. It's not just me who's saying that autonomy and transparency are critical for sustainable software design. The German Environment Agency released eco-certification criteria called the Blue Angel for software in 2020. And in the criteria, they recognize three main categories. So transparency and resource and energy efficiency, potential hardware operating life, and user autonomy criteria. And I'm going to go over these throughout the talk and then come back to this at the end. And this is the main model that's going to drive the entire conversation. So on the bottom here, you just have the linear model. The linear model being reduced to produce, use, and dispose, or more specifically, energy and material input, production, distribution. Is the sort of production, transportation, use, and then disposal and waste and emission leakage. And I'm not a great designer, but I tried to put this sentence interrupting the entire thing because one of the main questions I'm going to try to answer throughout this talk is how does FOSS interrupt the linear digital model and enable a circular one? And I'm going to relate some of these sort of first order principles of FOSS, how it's influencing what we're doing at KDE and the KDE Eco Initiative. Okay, so that's the background. But let's talk about what the problem is. So what's the problem? What are we trying to address by talking about this and focusing on it in KDE? And how does it relate to software? So many people think of software as being something immaterial, but it's software that determines the energy consumption of hardware, and it's software that determines how long you can use a device. So going back over 150 years, there was the first study done on the greenhouse effect. It was by Eunice Newton Foote, a woman scientist who, when presenting the study, was actually presented by a man and only later attributed to her in the publication. In the study, looking at various gases and the effect of the sun on them, found that the highest effect of the sun's rays was in CO2. The receiver containing carbon dioxide became itself much heated, and on being removed from the sun was many times as long in cooling. Okay, this is 150 years ago. Over 100 years ago, the environmental impact this could have was already pretty well known. This is from an article in 1912 from Popular Mechanics magazine. And it states here that adding CO2 tends to make the air a more effective blanket for the Earth and to raise its temperature. This effect may be considerable in a few centuries. And we are now in that time where the effect is considerable. This is just from earlier this year. It's you probably can't read all the details in the graph here. This is from a climate scientist at the University of Reading, Ed Hawkins, in which he notes that changes are emerging across the climate system. That's shown in all of these graphs here. This is from pretty much the last 50 years, and they're all going up rapidly with one exception. Everywhere we look, the climate is changing rapidly. These changes are not natural. They are caused by the burning of fossil fuels. So these graphs are representing here carbon dioxide, ocean warming, sea level rising. The only one that's going down are the polar ice caps in terms of the ice. And then the quote that I mentioned earlier from the Pope, this is from just a few weeks ago, a publication which is pretty scathing in its critique of the role or the lack of action from governments, and very much in favor of environmental activism. And in it, he says, "I have realized that our responses have not been adequate, while the world in which we live is collapsing and may be nearing the breaking point." What does this have to do with us here? So these are some estimates of the greenhouse gas emissions from the ICT sector. This includes everything that can be estimated, so production, transportation, end-of-life treatment, things like machine learning training, usage from end users, data centers, networks, etc. And in the research estimates, it's found that the contribution of the ICT sector is on a par with the global aviation industry. So somewhere between 2 and 4% of global greenhouse emissions come from ICT sector. The aviation industry is about 2.5%. And if nothing changes, if it continues on the trajectory it's on, it's estimated it can go up to 30% of global greenhouse gas emissions by 2050. And this is from a report from the Association of Computing Machinery. And they point out a couple of the main factors contributing to the rise in greenhouse gas emissions from the ICT sector. One of the main ones is machine learning and training of AI models. Between 2012 and 2018, it was increased by about 300,000 times. From 2018 to 2021, when the report came out, it was doubling every few months. I'm sure that's much higher now, given recent developments in AI and machine learning. Another factor that's an important one, which is the number of internet-connected devices, in particular short lifespan devices, which is expected to increase to about 75 billion devices in the next 5 years. Yeah, that comes with huge environmental impacts, which I am going to talk about in this talk. Okay, so this is the linear model. And it's just to point out that all of these stages apply to both software and hardware individually. We saw some of this in terms of hardware in the frameworks talk in interrupting this model. We saw some of this in the Fairphone talk. Today, I'm going to talk about where the two, so software and hardware, intersect with a particular focus on software. And I'm going to talk about it in 3 ways. I'm going to talk about lean software for longer and more efficient hardware use, vendor independence for hardware reuse and repair, and software recycling for new hardware support. And these are ways that we can interrupt this model, and I'll go into each of those in detail. So what do I mean by lean software? The efficient use of hardware. So doing the same task with fewer hardware demands. And this is relevant for the use stage of the linear model. This is a study from the German Environment Agency in which they compared word processors doing the same task in terms of energy consumption. The user emulation is referred to as a standard usage scenario. They compared various software products. I'm just focusing on the word processors. And they compared, in this case, an open source, that's all they identify it as, which is on the left, the green bar plot, with a proprietary word processor, which is on the right. And as you can see here, the energy consumption of the proprietary one was 4 times more than the open source one. And this is, again, to do the exact same thing. Okay. Now, for an individual user, this might not mean much. But when we talk about these things, we have to scale it up. Right? When we talk about software, it's distributed across millions of devices. When you think of word processors, every university, every home, every student, every doctor's office, et cetera, has a word processor running on it. And this is an example taken from an online course on sustainable software development from Detlef Toms, in which a back-of-the-envelope calculation is done to look at what would happen if you just reduce a process by 1 CPU second. And 1 CPU second reduction would be about the equivalent of 10 watt-second savings. That's nothing. Multiply that by 1.5 million users, which is a very modest assumption here. Making the assumption that that reduction is relevant 20 times and 20 interactions in a day, and that occurs 230 work days a year. right? That adds up to 19 megawatt hour savings. This is from one CPU second reduction. If you want a comparison of what that might be the equivalent to, that's like driving a modern electric vehicle from Paris to Shanghai 6 times back and forth. Okay. I've been giving similar talks now for the past year and a half, 2 years, and if I can convince 500 developers that this is worth taking seriously, and each of those developers just makes 10 of these very manageable reductions in their software, multiply that by the 19 megawatt hour savings, and we're talking about 95,000 megawatt hours. That's roughly the equivalent of the annual energy consumption of 30,000 two-person households. Okay, so a small city. Another way you can think of this, flip it around, if you add more processes to your software, you're increasing the energy consumption potentially by the annual consumption of small cities, okay, once you scale it up. So this is one of the motivations that is motivating KDE to start measuring our software. This is a usage scenario report from Ocular, looking at the energy consumption over time when running various tasks in a usage scenario. This is from the report that was submitted for Ocular to receive eco certification. And yeah, this is something that we're starting to do. We want to integrate it into the general development process so we can take a look and publish information about how much energy our software consumes. This summer, with some great work by a KDE contributor, Karanjot Singh, together with help from, in particular, Volker Krauser, among others, has now integrated this into the CI pipeline so that when a developer wants, they can trigger the measurement process. This sends the usage scenario that needs to be prepared in advance into the KDAB measurement lab here. The lab consists of 3 main components. You have the system under test, that's computer running the software that we want to test. This is following the Blue Angel criteria with off-the-shelf hardware. It's a Fujitsu desktop PC. This is connected to an external power meter, which is just measuring all of the power draw while running that usage scenario. And all of this is then being triggered, and then the data is being collected by a data aggregator and evaluator. It's just a little Raspberry Pi. This is all sitting in the KDAB Berlin offices. They've been very generous to offer us space to set up our lab. The analysis, so that the usage scenario will run however many times that you think are necessary. The Blue Angel recommends 30 times for statistical reasons. You can run it 1 time, you can run it 3 times, 5 times, whatever you think is necessary. For the analysis part, it's looking at the energy consumption driven by the software itself. So you want to subtract out the baseline energy consumption from the operating system, as well as the energy consumption from the software when it's running idle. Okay, so that's all part of the measurement process. Once you've run those scripts, they can take, depending on how many times you run it, between maybe an hour to 5 hours. You get then the results back from a tool called Oscar, which gives you a PDF with various graphs and summaries of the data the energy consumption, and then that gets it's created as an artifact in GitLab, and then the developer can download it and look to see if changes were made to improve the software or if it's gotten worse, etc. This is still very much a work in progress. If you're interested in this, we want this to be set up for free software developers. So the KDE Eco Initiative is under KDE, but this project and the projects, the Veaugh-Geiss for FOSS, the Free and Open Source Energy Efficiency Project, K-Eco Lab, we want to be part of free software development in general. Some details about the way that that pipeline works. There's the build phase in which the Flatpak is installed on the lab computer. Then there's the energy measurement in which the emulation is run, and the data is then sent to a tool called Oscar. That's the open source software consumption analysis in R tool. It's developed by the Umweltcampus Birkenfeld, the environmental campus in Birkenfeld. And then that gets then, the script is run, the data is then sent back. Okay. This is all related to use, right? And use is just one phase in the linear model. And in fact, we haven't interrupted the linear model at all, right? This is just related to how much energy does software consume. There's really nothing particular about free and open source software in this at this point. So what I want to focus on from here out is, oh, sorry, I got ahead of myself. After the use phase, you have the dispose phase, right? That's where hardware in particular is what I'm going to focus on, gets sent to, or maybe sent to a end-of-life treatment center or a landfill, or it might end up in your drawer, or we don't know. And there's various issues related to that. So as mentioned earlier in Luca's talk, the dark side of e-waste, right? There's a lot of e-waste being produced. In 2015, Achim Steiner from the United Nations Environment Program commented that there's a tsunami of e-waste rolling out over the land. In 2016, about 45 million tons of e-waste were produced. That doesn't really mean much to me. It helps me to think of it in terms of comparisons. One estimate suggests that would be the equivalent to the material for 4,500 Eiffel Towers. That still doesn't really mean that much to me, but that's represented here in this plot. If you were to take those Eiffel Towers and stack them up, that would be the equivalent to over 17 Mount Everests of e-waste in 1 year. Okay, so this is a lot of e-waste, and that was 2015. In 2019, the World Economic Forum commented that e-waste is the fastest growing waste stream in the world. In 2022, 60 million tons, so a 30% increase from 2016 was produced, and that's only increasing. Less than 20% of e-waste gets recycled, so if you have devices, send them to Fairphone. If it's supported, recycle them. Let's do this responsibly. For the e-waste that ends up in landfills, it only contributes about 2% of actual physical space in the landfill, but it contributes 70% of the toxic waste. Okay, so e-waste is a real issue. This is also presented earlier. This is the waste disposal center in Accra in Ghana. In the best case, this is releasing toxins into the air, into the soil, into the water. In the worst case, it's unregulated. There's scavenging happening, and this is causing health risks to the people doing so. So this is in Ghana. This is just in the West Bank. This is from the burning of the cables that was mentioned also earlier in the Fairphone talk. This is during the day. The sun is here. This is in the West Bank, where this is also an issue. It includes also Thailand is another big area for e-waste. So there are very serious environmental aspects to the dispose phase. And then to replace those discarded devices, you start the process over, right? And then you have all of the energy and material input, production and distribution, which also has its own problems, right? This is from the 2019 Apple internal report. It's published, but it's a life cycle assessment of their products in terms of sustainability. And they estimate that for the iPhone 7, over 80% of the greenhouse gas emissions for that product over its life cycle, which is estimated at about 3 years, is in the production, transportation, and disposal, in particular production. One thing to note, I just noticed that the Fairphone has a lower overall CO2 associated with its life cycle. It'd be interesting to look at the details about that. Exactly. So, okay, usage is actually just a small part of this. And another thing to note is that in the book where I was made aware of this data, it's a book called Smarte Groene Welt, Smart Green World. They compare the increase in production costs over time, and they find that although the earlier models maybe had a similar equivalent overall CO2 estimation, it's increasing in terms of what's going into production. And that's largely for newer chips, et cetera, requires different materials, and that's ever more energy consuming. Okay, and this also comes at huge social cost, which is why things like Fairphone and their emphasis on the supply chain is so important. So this is a picture of child labor in the Congo. The Congo is basically a dictatorship, and yeah, there are human rights violations happening to produce the cobalt to make our batteries, as one example. This is from a picture related to an article about the Supply Chain Due Diligence Act, which is a new law that just came into place in Germany, which says that companies have to be aware of the potential human rights abuses in their supply chains, and if they don't try to fix them, they can face fines. That might mean we all have fair phones soon in Germany. Yeah. And software design plays a critical role in all of this, right? Software bloat, feature creep results in messages like this device doesn't meet minimum system requirements. I know family members of mine have had this problem with laptops that aren't that old. It's one of the ways I convince them to try out Linux. If abandonware or planned obsolescence, this device is no longer supported, right? And the result is that functioning devices are discarded and new devices are produced and shipped unnecessarily. And so how does FOSS interrupt this linear model, right, of produce, use, and dispose? And that's going to be the rest of the talk for now. And the first point I want to make is about software freedom. So the free and open source aspects that are inherent to FOSS, enabling lean software to combat premature hardware obsolescence. So if we go back to this comparison of the two word processors, and look at them over time. So on the x-axis you have time, on the y-axis you have the power draw. The top plot is showing the proprietary software product, and the bottom plot is showing the open source one. And I'm going to focus on what's happening after this sort of neon blue line. This is the point at which the document is saved and the software goes idle. And what you can see in this plot, and this is again from that German Environment Agency report, you can see that the top plot continues to do things. It's continuing to pull energy. What exactly it's doing is not clear. It's not stated in the report. I don't know. It could be telemetry. It could be preparing for other processing. What you do see is that the open source product actually goes idle, right? So when thinking about this in terms of lean software, if it's proprietary software, you're dependent on the vendor to improve that software. You can't do anything as a user. And I'm using an example here from a delightful children's book from the Free Software Foundation Europe. This is an example in which there's a world in which one software developer controls most of the devices. Here you have a skateboard, toilets, ice cream machine. And in this book, it describes a situation in which, with a key, the main developer in this community could make all the ice cream machines dispense only vanilla ice cream. And sometimes people were disappointed when their flavor wasn't available, but what could they do? Right? They were dependent on the vendor. The name of the book is Ada and Sangaman, A Tale of Software, Skateboards, and Raspberry Ice Cream. It's really a nice little book. It's a great gift if you want to explain to people what you're doing for adults and for children. And one of the main points I want to make here is that the 4 freedoms that come with the transparency and autonomy inherent to free software, the use, study, share, and improve, mean that if there are inefficiencies in your software, you can do something about it, right? And this is one of the things that's happening in KDE. If you want to contribute, you're welcome to. We've started tagging things related to, so merge requests related to efficiency with an efficiency tag. We also now have tags for inefficiency in our bugs. Since we've started doing this is just from the last year and a half, we've had over 350 MRs tagged with efficiency, the efficiency tag. This is related to things like, anything related to freezing, spikes in CPU usage, et cetera, et cetera. This gives us a way to start tracking how we are doing and making our software more efficient. Anyone can contribute to it. That's one aspect to it, but there's another aspect, and I think there are 2 more that I'm going to talk about in terms of lean software. And I'm going to talk about this. I think we take this for granted in the free software community, that you can uninstall things, right? This is sort of a duh. Of course you can, right? Just put in the command and you've uninstalled it. This is not a given. And when you have those unwanted software components remaining in your system, they're going to cause inefficiencies that add up. Think back to that example with just that one CPU second reduction. If you think about all of the ways that those inefficiencies in terms of your boot up time, shutdown time, the use of your RAM, et cetera, are contributing to energy consumption that you don't want, being able to uninstall makes your software more lean. You can also often install what you want and nothing more, nothing less. You don't need to install the entire thing. You can install what you need to use, and that's it, right? And those contribute to a lean software design. Another one that I think we take for granted is the freedom of offline capability and freedom from advertising. Now, KDE has a policy of opt-in, so by default, any telemetry is off. If you want to, you can help contribute information to us by turning it on. This is a report for the EU about the carbon footprint of unwanted data use. And what they refer to as unwanted data use is the types of tracking that users cannot turn off. And this is within the EU. And I like this plot because it shows energy consumption both in the network and data centers. And they estimate that about 60% of EU citizens would turn off certain types of tracking if they could. This is based on some questionnaires they've sent around. And that unwanted data use contributes between, the carbon footprint of between 350 and 950,000 citizens in 1 year. Okay, this is for something that people don't want. So being able to turn this off, this is really low-hanging fruit, but this is something we are already doing, right? And emphasizing this, that this has sustainability benefits is huge. And one of the things that we're doing in KDE is we're trying to focus on awareness raising by documenting the various ways that our software, being free and open source software, contributes to a more sustainable software design. This is also a work in progress. Hopefully it will be integrated soon. An eco tab in our software alongside our about information, our authors, our thanks to, et cetera, highlighting the ways that this software, being free and open source software, has sustainability benefits, as well as any links to measurement reports that we're doing in our lab or eco-certification if we pursue that for other software products. Okay. That's in terms of the longer use phase, but now let's look at reuse, right? FOSS makes it possible to give old hardware new value. This is a real example. It's a laptop, a MacBook from 2009. The end of support was 2019 with macOS 10.10. This is still being used by a KDE contributor running Ubuntu 22.04, up to date, works great. This would otherwise end up as e-waste, but given that there is a software alternative that runs up to date, that's not dependent on the vendors, you can keep using this hardware. This is just an example again from the children's book Ada and Zengaman. This is going back to that ice cream machine. It's an example where the Ada, the protagonist of the book, was able from a broken ice cream machine to build a new one that can make ice cream in every imaginable shape and color. Right? You can do new things with that old hardware when you have access to the source code. And this need for software repairability, so what I mean here is that we can continue giving security updates in this context, right? That we can patch the software, which you can't do once proprietary software is no longer supported by the vendor. This is a report for a circular economy from the EU from 2020. And they note that value is lost when fully or partially functional products are discarded because software is no longer supported. And with a focus on electronics and ICT as a priority sector for implementing the right to repair, including a right to update obsolete software. And this is an open letter to EU legislators from the FSFE, the Free Software Foundation Europe, as part of the Upcycling Android project. I'm going to question, how can you have a right to repair without software freedom? I don't know what it means to have a right to do something if you can't access the things that are needed to make it run, right? So FOSS here, again, I think is necessary to enable a circular economy in terms of repairing devices so that you can reuse them. Okay, and this is the last aspect of the circular economy that I'm going to look at, recycling, and I'm going to talk about it in terms of software recycling. There was just a talk right before mine, and I'm really honored to be able to talk about their project after them. It's a really amazing project, the Asahi Linux project, and free software gives you the freedom to integrate with existing code, right? You don't need to reinvent the wheel. They're doing incredible work to make Linux work on the M series chips, but they don't need to do everything. They can integrate that into existing code bases and provide usable operating systems on new hardware. And one of the important things about that is that if you go to this entire model, by recycling software so that you can support new hardware, that's going to influence all the stages down the line, right? So that when you get to the use phase, you can improve it, make it leaner, make it run so that it consumes less energy. When the vendor no longer supports that hardware, we can continue supporting it by patching the software when needed, et cetera. So this has effects down the line. So to come back to the Blaue Engel, the Blue Angel eco-label, as I mentioned earlier, they recognize that autonomy and transparency are crucial for sustainable software design. You don't need to be free and open source software to be eco-certified, but there's an advantage because you're developing free and open source software, you're already fulfilling many of the criteria. This is a summary of the three main categories. So to be eco-certified, you need to be transparent in terms of your hardware performance and energy consumption, your minimum system requirements, as well as your support for energy saving modes. You have to run on hardware at least 5 years old. Now, this seems very low to me. I think we could do you could run on much older hardware, as many Linux enthusiasts are. But the real false advantage comes in this user autonomy criteria, where documentation of your support for uninstallability, modularity, continuity of support, offline capability, freedom of advertising, documentation so that that software can continue to be supported over time, transparency, that it's either it's open source, so the APIs support open standards, things like this. FOSS is already fulfilling many of these criteria. It's a matter of documentation. KDE is proud to be the first ever eco-certified computer program in the global eco-labeling network. We applied for eco-certification of Ocular about a year ago, and earlier this year, last year, we're certified. If you're interested, we have documented the entire process in a handbook. Covering many similar topics to what I've talked about today. You can download it from the website eco.kde.org. The title of the book is Applying the Blue Angel Criteria to Free Software. It's right now in 3 parts. We're including a new chapter soon. The 3 parts are the why. Why is this important? Covering many similar topics to what I presented at the beginning. What is the Blue Angel? What are the criteria? What does uninstallability have to do with energy savings, things like this? And then maybe the most important one for software developers, how do you then measure your software? Perhaps some of this is no longer necessary if you want to use our lab. It's now mostly automated, and hopefully we can continue in that direction. KDE last year, this time, adopted 3 new unifying goals for the community. One of which was sustainable software. And it's now a focus of the community to focus on ways that we can create a culture of sustainable software design, raise awareness how free and open source software, and KDE software in particular, is more sustainable, and looking at energy consumption of our software. And I have a few slides after this. They're kind of like tooting our own horn kind of slides. but in case I didn't have enough time, I wanted to put this here. I like to conclude some of my talks by raising the question I think many people ask: is all of this worth it? Right? Adding extra steps into the development process. There are bigger problems, et cetera, et cetera. And of course, XKCD has a comic that's relevant. And here it's, cue ball and white hat talking, and cue ball says, "I'm trying to fix a problem with the world. Can you help?" And white hat says, "It's obvious you don't actually care. If you did, you'd be trying to fix this bigger problem instead." And cue ball responds, "Okay, you want to help me fix that bigger problem?" And white hat says, "No, for another reason I'll think of later." Right? So let's not be white hat in this and just find excuses for not doing something is maybe the first thing to say. But I would also say there's a logical fallacy in this kind of argumentation. Saying there's a bigger problem, that might be true, and I think there are bigger problems, right? But that doesn't mean the other thing is not a problem. And I hope I've shown you that there are various problems related to software development that are relevant and that do have an impact. Another thing to think about is what resources do you have at your disposal, and what is your likelihood of success? So tackling the biggest problem may not be the most effective strategy. We're software developers. I'm not actually, I'm an enthusiast, but many people here are software developers. You have agency. You can do many of these things. You can start thinking about this stuff, and it does have an impact. Thinking of just one CPU second reduction when you scale it up can have huge energy savings. You can do this, right? We can make these changes and start bringing this into the culture of software development in free software communities. And yeah, the last point is that software does have big impacts. So I hope that I've convinced you of that. And again, this is, so quoting the Pope, I like this quote. I like it as a sort of a summary. Every little bit helps, right? And avoiding an increase of 1/10 of a degree in the global temperature would already suffice to alleviate some suffering for many people. And this is maybe even more important to me. It's something less quantitative, right? We need to realize that there are no lasting changes without cultural changes, which is one of the things I'm really trying to do in the work that I'm doing with KDE Eco. And there are no cultural changes without personal changes. So we need systemic change. We also need individual change, and we can do this. I'm just going to toot our own horn a little bit. There's been a lot of outreach related to the KDE Eco project, in particular after certifying Ocular, which raised awareness of what we're doing. There was an invitation to join the Green Party at the German Parliament for a Sustainable by Design conference. Cornelius Schumacher, who's been really influential in this entire project, attended as a guest speaker, among many other people like Cory Doctorow and big-name German politicians. You can read about it at the blog. In the House of Lords in London earlier this year, or maybe it was end of last year, there was the Open UK Awards. Here you can see KDE contributor Jonathan Riddall, who joined together with the Francis Maud, who was a member of the House of Lords, who was influential about a decade ago in creating a website for information about open data and open formats in the UK. We were there as co-hosts for this Open UK Awards. This is a partnership with FOSS Nigeria, working in remote areas, teaching children, the Almajari children, so they're focusing on education, but they also are focusing on sustainability aspects of this. One reason is they want to have control over the devices, so they're using free software, in particular Plasma Mobile. It's also interesting they're running a lot of this on solar energy, from what I understand, because it's not the areas they're going to are not connected to the electricity grid. So this is something that we're also involved in. We've had a lot of work in Season of KDE, working on some of the tooling. There's a KDE Eco Test, which is an emulation tool based on XDo tool with Python to emulate user behavior for creating usage scenarios. We have some preparation for Blue Angel certification, and then Selenium scripting, which might be the next chapter in our handbook, using Selenium to emulate user behavior, which can also run on Wayland. Right now, most of the emulation we're doing is on using XDo tool, so it's only in X11. We want to also look at the efficiency in Wayland. This has been reported on in a German magazine, heise.de. Selenium in particular is quite interesting to us. It covers many different aspects of the three main goals in KDE. You can also read about it at our blog. There's a sustainable software awesome list at the repository. You can check it out, featuring links to many different projects. And then just to give a shout out to a couple of projects that are doing things that are relevant to what we're doing and have collaborated in some way with us. There's the Free Software Foundation Upcycling Android, which is keeping smartphone devices in use with Android derivatives. There's the the Sustainable Digital Infrastructure Alliance. Next month in Berlin, they have a Green Coding Summit. They've also been influential in the work that we're doing in KDE Eco. And then the Green Coding Berlin, which is also developing tooling for measuring the energy consumption of software, also been involved in some of the lab setup aspects of what we're doing at KDE Eco. And finally, the Green Web Foundation, they're doing estimates of energy consumption related to websites. So all projects worth checking out. There's many ways to get involved with us. If you're interested, check out our website, eco.kde.org, contact me. We have a monthly meetup the second Wednesday, so next week. Next week, we will be talking about Selenium. So you might be interested joining to check out what we're doing there. Mailing list in a matrix room. And just one more time, the slides. So that's the end of my talk. Thank you.
We have time for a question or two if anyone wants.
Thank you very much for such a presentation. You have mentioned several steps about what each organization could do to make their software more sustainable, but could you provide some examples on what we as individual developers or enthusiasts could do on a personal level to help the sustainability? Thank you.
So as a developer, in terms of actual coding, I'm not the best person to ask because I'm actually not a developer. There are many things that you can look at. If you look at CPU spikes, that correlates often, not always, but often with energy consumption, and trying to fix those kinds of bugs will have an impact on the energy consumption overall in your software. One thing I would think about is ways that you can implement maybe some of those user autonomy aspects into your software, things like opting in instead of opting out, so things are shut off by default. I know that isn't necessarily what you want as a developer, but these do have sustainability impacts. Things like this I would recommend as sort of low-hanging fruit. Those are just two things that come to mind. I'm sure there's very specific things in each individual case that, I can't really address, but if you want to talk and exchange ideas within our community, you're always welcome to join our mailing list or matrix room or come to our meetups and ask questions where people who are much, much smarter than I am can maybe give you some tips.
Hi, thank you for the presentation. I've been thinking a lot in the past few months about our continuous integration systems. So for any given software that you can imagine, we're basically booting a machine, installing basically the same dependencies that we just installed 5 minutes ago, and doing lots of crazy stuff, and running tests for half an hour. And are there any measurements of how much does that contribute to the whole footprint of the ICT industry?
No, but that's something that we have talked about also in our community. So that's one thing when looking at this linear model. That's the software production phase, a software which has its own carbon footprint and is embodied in the software release that you have, right? That's the embodied carbon of a software project. I don't know of any particular projects looking to quantify that yet. I still think we're at such an early stage in this, but that's certainly on the radar, and I think it's a very relevant topic. And I think it will be interesting if you work on that, or if anyone here ends up working on something like that. Yeah, come talk to us, share what you learn. But yes, that's a very relevant point. There's a lot of energy consumption happening in just our CI pipeline. Right. And that's also one of the reasons the measurement process is not triggered automatically. It's something that has to be manually triggered so that we don't want it running every time, right? That counteracts what we're trying to achieve here.
All right, that's time. One more thank you to Joseph.